Good morning, everyone. Welcome to this session where we will explore how to design cooling units that are both profitable and suitable for its intended use and demand. My name is Pablo Ses. I work at BASE as a sustainable finance specialist, and I have here today with me an excellent panel of experts with Giovanni, Florian, Sonia, and Philippe, that they will be sharing with us their insights on this topic. But maybe before we start with the introductions, I would like to start sharing with you our experience at BASE with cooling units. It is true that BASE has been collaborating in several projects in the last years involving cooling units in different regions of the world, but it is also true that it has not been until very recently where we had the challenge of defining, sizing, procuring, and deploying real units ourselves in a particular project. No, the pictures on the left, on the bottom left of the slide shows this particular project we are working with currently. This is a project in Guinea-Bissau, where we are particularly taking this role of implementing the units. No? So in order to move forward this project, we had to face the challenges that shape a little bit the session we are sharing with you today, because we had to make ourselves the questions that will be guiding a little bit the intervention of the different panelists. No? Starting with how do we size correctly our cooling unit, no? Especially in a context where maybe the demand side is not always fully defined. No? And then moving to the next question, no? How do we select the energy generation technologies that we need, no? Considering the particularities of the location of our projects, no? Or our cooling units. In our case, these units were to be deployed in isolated areas in most of the cases. No. Also, how do we choose the right energy storage technology? No, and what let's say what autonomy do we give to this system? And moving also to next question, how do we incorporate good environmental choices in our designs, no, considering these locations? And finally, one important question, no, regarding quality, no, how we make sure that our suppliers are going to design and deploy and commission the units according to the specifications of our project, no? Especially in a context like it was our case, where we were managing this project from abroad, from Switzerland and other European countries, and we had limited resources to be on the ground checking for the construction and commissioning activities as they evolved in the different locations of our projects. No, so I would like also to share with you one important resource that we use to navigate all these challenges, which is the guide that you see at the right-hand side of the slide. It's a practitioner technical guide for designing cooling units, and it proved to be very useful for us defining all these questions that I was mentioning before, and that will shape a little bit the session of today. No, luckily for us, we have today with us also as a member of our panel of experts, Mr. Giovanni, who co-edited this guide, and I think it is now maybe the time to have a quick round of introductions of our experts, where they will take 1 minute each to introduce themselves. Hello, Giovanni, and then we move to the topics of the session itself. So, Giovanni, the floor is yours. You can introduce yourself.
Thank you, Pablo. Hope you can hear me well. Welcome to everyone. I wouldn't say good afternoon, good morning, good evening, because I don't know exactly where you are, but I'm a professor of thermodynamics and heat transfer at the University of Udine in Italy. I lead a refrigeration research group We deal especially with both residential, commercial, and industrial buildings. We focus on plant configurations, trying to enhance the efficiency of refrigeration and heat pump systems, especially with natural fluids, which are very important today to reduce carbon dioxide emissions. I'm also quite involved in the activities of the International Institute of Refrigeration because I'm the Italian delegate to the institute and I'm a member of honor of this institution. In the past, I served as president of the Commission on Refrigerated Storage, and the reason why I'm here is because, as you mentioned before, Pablo, I co-edited together with Jeremy Tite a guide, the working cold room technical guide of the IIR, which we are presenting now this afternoon. So thank you, and I say
Thank you,
it's enough for
Giovanni.
me.
Thanks, Giovanni, for your introduction. Maybe Florian, now you can come. The floor is yours and present yourself. Thanks a
Yeah.
lot.
Hi, everybody. My name is Florian Martini, working for the company Faesan. In my presentation later on, I have just two slides to present the company. So for now, just very short. So we started about 10 years ago working on the solar cooling sector. And for the last 5 years, we've been focusing then a lot on solar cooling appliances, specializing on walk-in cold rooms and milk cooling. I think that's fine for now. I will talk a bit more about who we are in my presentation later on.
Thanks, Florian. Maybe Philippe, maybe you can take the floor and present yourself. Thank you very much for joining us today. I think you are muted, or at least I cannot hear you well.
Yeah, from Accra. I'm I work for GIZ. I'm based in Nairobi, but I work globally on sustainable cooling, also solar cooling. I mean, GIZ has a lot of cooling projects and programs, and I'm advising most of them. So I deal with any type of cooling, and I'm also working over the last 11 years on solar cooling.
Thanks a lot, Philippe. And finally, Sonia, maybe you can introduce yourself as well. Thanks a lot.
Yes, hi, good morning, afternoon, evening to everyone. My name is Sonia Mettenleiter. I'm also based in Nairobi, Kenya, and I'm a consultant for sustainable cold chains, coming also from the agricultural perspective. And I've spent the past 5 years a lot in the field, especially in Eastern Africa. So I've seen a lot of things that work and don't work. And today I'm here to represent the Verisol program of CLASP, where we are currently writing a quality assurance framework for walk-in cold rooms. And quality assurance is extremely important, but you'll hear about that later from me. Thank you.
Thanks a lot, Sonia, for your introduction. Maybe we can move now to the first section of the session where we will have a more closer look to the guide we were presenting or introducing earlier. This is an important document that shaped a little bit the initial stages of our project, and I think it has a very interesting component, which is that it is very close to practical advice. No, so maybe Giovanni, you can take the floor again and share with us your insights on this guide and your expertise. Thank you very much.
Thank you, Pablo, for your introduction. Well, Pablo, the starting point of this work is the awareness. I hope you can see my share screen. Okay, perfect. Is the awareness that about, I would say, 13% of the food produced in the world for human consumption is lost. More than 21% is lost in sub-Saharan Africa, while some estimate much higher losses of around 1/3. So at the same time, population is growing fast, especially in those countries in Africa and Asia where the population relies upon rural or traditional food systems. So therefore, rural economies in the global south must be a major focus to help reduce food loss and to improve nutrition in the earth. The International Institute of Refrigeration from its very beginning produces books and guides to promote good practices in refrigeration. Also in warm climates, the yellow guide is shown there. However, some attempts to improve the cold chain in the global south failed in the past, not for technical reasons, rather for wrong choices at the planning stage or wrong operation. So this led to the idea of a brand new book it was in 2021, I would say, starting from a practitioner perspective and not just purely technical. This work was done with SMAP and its efficient clean cooling program, as well as efficiency for access, with their funding and mostly with their worldwide connections. So a strong team could have been built involving people with not only technical background, but also with field experience to give a practical, solid advice in the guide. And the approach we followed is an holistic one because it's needed. We start from a thorough planning supported by data analysis and policy and regulations from the governments. For example, I wouldn't mind the national cooling action plans in an environment where people are aware of the benefits of using cold storage. So we need training of farmers and market owners, where cutting-edge technology can be employed to improve effectiveness and reliability of the systems. So we need training of designers and technicians, and where partnership and links are established among farmers, stakeholders, and all actors. And finally, where access to financing is made easier. So it's quite complicated, and trying to summarize the purpose of the guide, I would say that it is to present accessible, practical guidance that enables developers, owners, operators, and suppliers to specify, install, and operate effective and appropriate pre-coolers and cold rooms that are as economically viable as possible in off-grid, unreliable, and limited power supply situation. So you see this slide is full of keywords which are all very important and represent the core of our work. And the guide mainly deals with working cold rooms, which are a primary link in the cold chain, preventing perishable products from being discarded and sustaining their nutritional value. However, cold rooms in hot climate conditions and unreliable power supply are extremely challenging. So manufacturers are learning day by day how to design and operate them, and we want to give them a tool as much as possible. So the key points of our guide are: we deal with working cold rooms up to around 80 cubic meters, mostly with sandwich panel construction. We don't move to higher cubic volumes, but however, most information can be extended also to larger size. Horticultural and agricultural products are considered, so not fish, not meat, not bulk meat cooling, not ice production, healthcare, vaccines. They need specific conditions. And also chilled storage only is considered, not frozen. When it comes to the cooling system, only electrical driven vapor compression system technologies are considered in favor of reliability and simple maintenance. Their skills should be available locally. We assume there are. There are also simple solutions like, for example, passive cooling by shading or evaporative effect, or pre-cooling of warm produce from the field. But we do consider them, they are not covered in detail in this guide. Reliability and affordability are priorities. However, such technologies, to be reliable and affordable, are also expensive for some markets, and therefore some financing and business models are to consider, and we did. Suggestions for a correct planning are therefore given for the best exploitation of the investment to avoid the white elephants. There are numerous white elephants, unfortunately. And finally, further reading is also signposted because further suggestions or alternative and complementary solutions could be interesting for the reader. So it's quite a wide scenario. And when it comes to the power supply, I would say that we consider both reliable, unreliable, and off-grid solutions, because all of them are very important. When we come to renewable energy, particular focus is given on solar photovoltaic energy source. This requires energy storage. So as you mentioned, we consider both electrical and thermal energy storage. It's important to mention that we don't consider fuel power generators because they have high maintenance cost, fuel cost, and negative emissions. So we move as much as possible with environmental sustainable solutions. Well, specifying a cold room into an agricultural value chain is quite complex and needs independent professional advice because solutions may differ considerably in different areas and markets. So we want to offer guidance through the steps to plan, specify, install, and run a cold room, trying to enable the reader to get effective discussion with the specialists and suppliers and funders. And here in this slide, you can see the path from the very first idea to an operative cold room. First of all, you have to check if a cold room is the right solution to the problem. Possibly sometimes it is not. You have to evaluate the market needs, the availability of technologies, and funding. So provided the cold room is the right choice, then you have to estimate the cooling loss depending on the purpose of the cold room. If pre-cooling is considered, a dedicated system should be used to reduce the pre-cooling time and introduce chilled food in the cold room. Based on this information, the size and the type of the cold room is chosen together with the refrigerating system to ensure the cold room can be effective. And the guide considers not only typical sandwich panels cold rooms, but also we consider pre-assembled cold rooms, the flat-packed cold rooms, refrigerated iso containers, self-built cold rooms, or converted shipping container, even if the typical sandwich panels is the most common solution and most affordable and valid solution. Once the site is chosen, the available power supply is known and proper configuration for solar photovoltaic production are suggested, together with effective energy storage solution to afford unreliable or even off-grid operation. Among the renewable energy sources, as I told you, photovoltaic is considered as the most common and reliable choice. Business models are then compared for the best exploitation of the investment and ensure the revenues generated is sufficient to cover the high investment costs. And innovative business models are then proposed, for example, service-based models. The most promising value chains are then to be identified. Reliable market access has to be ensured for logistics and operations. So finally, the business model should guarantee the highest utilization rate for the cold room, with financial routes, risk, and costs well known and correctly evaluated. So it's a long path. Finally, technical specification can be outlined and the no-go decision stage is reached. If we decide to go on, then the tender or procurement process starts, and then we move to installation, commissioning. Installation is a crucial phase. A good installation prevents from unexpected failures in the future and allows a long lifetime of the system. And also commissioning, and if the case testing, Sonia will possibly talk about that, is important as well for the same reasons. Finally, during the lifetime, the system has to be operated, maintained, and managed, and this is the last step in the guide. Well, this guide, and I'm going to conclude, this guide has been written on the practical experience of leading experts and suppliers across Africa, India, and elsewhere. And surely we wish to help suppliers and users to achieve the best solution for each application and to avoid common mistakes. The guide is freely available as a PDF file on both the IIR and the Efficiency for Access websites. You can see here 2 QR codes, and you can anyway log into the websites of both the associations. You will find both the guide on the left with more than 200 pages, but also an overview for a wider audience, less technical and most strategical. It's all for me by my side. Thank you.
Thanks. Thank you very much, Giovanni, for your insights and your
Pablo.
experience
Oh,
with this guide. Maybe now we can move to Florian, where he will be also sharing some first-hand experience with cooling units. So now, Florian, the floor is yours. Thank you very much.
Yes, thanks again. Also from my end, I think it's a great opportunity to be part of this community and to share experiences here, as we are a pretty young community in the solar cooling sector. And this way, in my opinion, it's really important to share the experiences to grow together, as the potential is really huge. All right, first of all, just some quick intro about Faesan. Here we go. Yeah, so the company has been founded about 25 years ago. We are based in southern Germany with a team of about 40 off-grid experts. We have partners and projects in more than 80 countries, focusing on the African continent with a product portfolio of more than 3,000 products from the off-grid sector. We're active in different fields of applications, and today, of course, I would like to focus on the solar cooling sector and our experiences in this field. First of all, we made experience that prior to an installation of a cold room, it is very crucial and important to do a comprehensive needs assessment on site to really understand the needs of the people and the different stakeholders at the cold room in order to make a suitable system design to avoid over or under designing the cold room. And so right now I'm only referring to the technical design and not on the business model development, which is actually the even more important part. So now I'm just referring to the technical design for the cooling capacity. And the main influencing parameters are, first of all, of course, the target temperature. So what temperature do you need in the cold room? And this depends on the crops that are using inside the cold room. Second is the storage volume. Of course, the bigger the cold room, the higher the heat losses. And then it's always worth it to consider an extended scope of services, meaning that if, as you already have a PV generator and battery storage, it might be a suitable solution to offer other productive use services, such as charging of phones or lighting. And then, of course, there's a whole range of productive use appliances like carpentry, oil pressing, crane milling, and there's many more options that are there to enhance your business model. So it's always worth it to consider that. And last but not least, the most important parameter with the highest impact on the cooling capacity is the daily input. So how much produce would you put in a cold room per day? And yes, we noticed that it's really difficult in most cases to estimate this number, but at the same time having the greatest impact on the cooling capacity and therefore also on the price of the cold room. So it's really important to take your time to consider this value. And to do so, you need to understand the whole value chain. So, and the whole value chain of each crop that you are going to store in the cold room. You already have to have a really developed business model to understand the different value chains. And also you have to understand the social cultural considerations. So being on the ground, talking to the people, to the different stakeholders, to also understand their behavior. So it's really crucial to take enough time to do baseline studies and to really get as close as possible to the daily input that is required for your cold room. Another challenge that is actually for I would say for all cold rooms are the high CAPEX. I mean, solar powered cold rooms are still pretty expensive. And this is why, in our opinion, it's really important to have a modular system design, meaning that you can start with low cooling capacity and therefore low CAPEX, but having the opportunity to later on scale the cooling capacity together with the sales figures and the business model that is then developing time after time. And how we implemented this with our DC-powered cold rooms with the self-chill technology that we have developed using thermal energy storage, where you can put a number of cooling units, starting with a certain cooling capacity, and after time you can just add more and more cooling unit to the same thermal energy storage, the same cold room, and thereby increasing the cooling capacity later on. Same thing applies to our AC powered cold rooms. So we are also offering cold rooms with monoblocks from different manufacturers. And same thing here, what we do is we design the basic electronic design in a way that you can later on just add more and more monoblocks to the same cold room by just cutting a hole in the cold room wall, placing the monoblock there and connecting it to the existing electrical system, of course, with additional PV and battery, but this is pretty simple and can be done by any solar technician. Another very popular question and topic is the calculation of the optimum autonomy for a cold room. And there's actually no definite answer on what autonomy is best for a cold room, as it depends on each specific case. And it's actually a trade-off between, on the one hand, having a reliable cooling performance of the cold room, and on the other hand, having a potential economic loss in the event of the cold room getting warm. And the influencing parameters for calculating the autonomy are first for hybrid cold rooms. You have to understand the probability distribution of power outages, meaning how often are they, how long are they normally, is there any seasonality, meaning are the power outages mainly maybe in dry season. However, in rainy season, you depend mostly on the cold room as then it's harvesting season. Or are the power outages mostly during the night when you heavily rely on the grid or the battery power supply? Or are they only during the day when you anyways have surplus solar power energy available? So this is why you really have to write down, sit down, do calculations to understand the power outages for the hybrid systems. Second thing is you have to understand the potential economic loss in the event of the cold room getting warm. So how much produce would you have as a maximum in the cold room? What is the value of the produce in the cold room? And what would be then the loss if the cold room gets warm for 24 hours? Having this number, you have to compare it with the additional equipment costs of an extended autonomy, meaning how much would it cost to increase the autonomy by adding battery capacity or adding thermal energy storage? And then you can compare the two costs with each other. And having all these numbers, you can then define the optimum autonomy for your specific cold room. But as a rule of thumb, we normally calculate with the autonomy time of about 1 day, which is then kind of the break even of or the most viable economic autonomy time. Another very popular topic is the comparison between thermal and battery energy storages. Same thing here. There is actually no definite answer which technology is the best one. So I would like to just compare some parameters so that you get your own impression. First of all, the energy efficiency. Of course, I think that's clear. Thermal storage, we have an advantage in terms of energy efficiency, as the electrical energy from the PV generator is converted to thermal energy, which is then directly used in the cold room. However, using a battery storage, you convert the electrical energy from the PV system to the battery and then later on to thermal energy. So we have additional conversion losses with the battery storage. The cost effectiveness. So if you would have asked me 5 years ago, I would have told you that thermal storage is definitely the better and the cheapest solution. However, as in the last 1 or 2 years, the prices for lithium batteries and inverters has decreased drastically. We're actually more or less in the same price range now, comparing thermal with battery storage. Of course, also depending on what kind of thermal energy you're using. Number 3, the lifespan. If just water used as a thermal energy storage. That's of course an advantage, as the water can easily be changed compared to lithium batteries having a lifespan of 8 to 10 years, more or less, which is actually already much better compared to the lead acid batteries that still have been used a couple of years ago. Environmental impact, I guess that's a no-brainer. So if water is used as thermal storage, that's definitely better compared to lithium batteries. And the last point, the flexibility, this is what I already mentioned. So having an electrical energy storage, you have the advantage of having the flexibility to also use this energy, not only for cooling, but also for other appliances that could enhance your business model. That's it from my end. Thanks. And feel free to contact me even after your event if you have any questions, if you would like to discuss the topics with me. Thanks.
Thank you. Thank you very much, Florian, for your insights. Now we have covered a little bit the design aspects from a general perspective through the guide and the insights with Giovanni. Now your first-hand experience with units on the ground. I think it is now time that we can move to a different angle. Maybe we can bring Philippe to the floor, where he will be sharing with us a little bit the experience and his insights, also covering the environmental aspects of all regarding the use of cooling units. So thanks a lot, Philippe, and the floor is yours.
Basically, I mean, I work under the Montreal Protocol and under the Paris Agreement, and here you see the countries where we are active as Proclima. But as you know, we are working in around 130 countries, and we have a turnover of around 4 billion. So we have a lot of projects, and I'm advising globally. I mean, I work a lot also in China or India, but my main focus currently is Africa. So we've been working over 30 years, controlling substances, CFCs, HCFCs, HFCs, in the countries, but we also combine like the climate change. So we usually do policy advice, technology demonstration, and capacity building, and we try to do leapfrogging to green cooling, meaning moving straight to natural refrigerants. In the beginning, there were natural refrigerants. Then we had CFCs, HCFCs, HFCs. Now we have HFOs, forever chemicals, and so on. So what we try to do, as I mentioned, is the Paris Agreement, the Montreal Protocol, its Kigali Amendment, plus the energy, we combine it, and we help the countries to phase out the substances. We also need to consider the Sustainable Development Goals. And I mean, all these countries globally now need to phase out harmful refrigerants, still ozone harming and climate harmful, but also only climate harmful substances. And here you see the overview. And I've been arguing the last 11 years with my energy colleagues, my renewable energy colleagues, because they always say, we do climate change and we do solar cooling. And then I look at their refrigerants, and as you can see, I mean, often they still use 404. And if you look at the GWP of 20 years, you see 1 kilo has 7.2 tons of CO2 equivalent over 20 years. And we want to fight climate change now and not in 100 years. So, and then I tell them, look, you cannot use 404. It's even banned in Europe. I mean, we're not allowed to import any or produce. We can use the existing 404. So, and then, but they say, but there's no manufacturer. And I'm like, and you're selling it as a climate change project. So to us, we only promote natural refrigerants. And I also try to promote, I'm involved in most of the GIZ cooling projects, also solar cooling, and I always advise natural refrigerants. And we have many examples I will present. You have to also see that it's not only the ozone impact. R22 still has an ozone impact. It is also the environmental impact in terms of PFAS and TFA breakdown. And I mean, in Europe, we try to ban it. And even if it's a nice HFO that has no climate impact, I mean, the production itself has usually a high climate impact. But then you see, you have like a terrible environmental impact, and those chemicals, I mean, also are called forever chemicals. So, and that's why we say natural refrigerants only. And I mean, looking at the safety standards, yeah, natural refrigerants usually come with flammability, but also most new substances and HFOs also come with flammability and toxicity. And so if you're looking at the safety standards, you can see that the charge of refrigerant is sufficient to power most of the systems. I mean, in most applications, especially on solar cooling. And the thermodynamics of propane is excellent also in hot climate temperature zones. We're having a nice revised guide on safety standards if you're interested. What is very important is training. You cannot just, I mean, a lot of the applications are plug-in monoblocks, as you could hear, and so on. You don't need a lot of training. There's no bracing. But if you have larger or more complex applications, you need to make sure that your refrigeration technician is properly trained, that maintenance is very important to operate the system. And of course, the operators also need to be trained. Here are some online courses free that can be also conducted by any technician online, or there's a lot of training material. Another important factor that most of the time is forgotten completely is the insulation material. And I still see a lot of cold rooms using 141B. That's an HCFC, so it has still an ozone depleting potential and a high climate potential. And this cannot be. But what I really now see is you have more and more HFOs with PVAS, you know. So you have a nice cold room, but they use HFOs for other chemicals, you know. And I'm dealing a lot with end of life. You need to look at the whole total life cycle of the equipment. So the production, the shipment, the use, operation, and end of life. So what are we doing? And I've seen a lot of insulation material in Africa laying around in the middle of nowhere or just getting burned up. And these PVAS, yeah, they can be found everywhere. So I'm really not a fan of, as you can hear, of the new HFO blowing agents and of walk-in cold rooms that use those insulation materials and claim they're environmental and climate friendly. So the batteries, we just heard it, and yes, I mean, I'm in favor of thermal storage because I look at the total life cycle emissions. The production in China, those batteries, as you can see, for a 21 square meter cubic meter cold room, you use minimum 1,000 ampere hours battery, and that's minimum, I mean, roughly converted 22,000 kilometers. Driving a car. And then you have the shipment emissions on dirty vessels. And then, I mean, you have end of life. There's no recycling batteries in most of the countries. I mean, I just talked to AFD last week in Kenya, and they told me, African Development Bank, they said, look, we couldn't finance anything because we had no end of life solution. And I mean, although, yeah, they might, I mean, I've seen many solar systems that have been down after 6, 8, 10 years maximum because the batteries are broken. And they had no money to replace it. And you have to replace it. And then what are you doing with the old batteries? So I'm really in favor, and we are mainly incentivizing only or sponsoring thermal solutions now. And although, of course, sometimes you cannot, and sometimes you have to combine it. But as you can see, I mean, one battery can have 196 kilograms of CO2 equivalent, 1 kilowatt. This is a nice drawing from Solar Cooling Engineering, and you can see you have the conventional system, PV, batteries, and you produce cold with a monoblock, for example. Then you have a system where you also have thermal storage, but still relies on batteries, or you have direct solar drive. I like direct solar drive with thermal storage. If it's possible, use that. Sometimes, yeah, it depends on the country. You have to still use more batteries, but we have a lot of system running now in many countries where we only use a small battery for the control unit, for the fan, you know, and for the pump that pumps the ice water, for example. This was the first cold room I designed with ILK, Dresden, and Cold Hubs together over 10 years ago. And that was the first system also that used R290 monoblocks, and that was a condition. And I mean, we have around 100, and this is a role model for many other countries. For example, also for Kenya. I come to it in a minute. We also used the natural blowing agents, cyclopentane, for the insulation panels and R290 monoblock. The first systems had batteries, but cold hubs also developed systems then with ice storage. And we just had the presentation. GIZ has been working a lot with self-chill and in various countries, Kenya, Ethiopia, Togo, Rwanda, and so on. I like the low-cost solution. It can be also built locally a lot. I think it's reliable, and you had the presentation before, so I don't need to talk a lot about it. But it also shows that thermal storage is quite a reliable and good solution and a cost-effective solution. I also did a fish cold room. Designed a fish cold room 10 years with ice production, also with R290 and a natural blowing agent for the insulation panels, also 10 years ago in Kenya. And I'm getting more and more requests from my colleagues on fish cooling. For example, now we do a lot of solar ice production, or we in Yemen, or so fish cooling. 1.2 billion people depend on fish cooling. So on fish, sorry, and also the cold chain for fish. Here's a publication, you can read more about it. These were the first 6 containers we used in Ethiopia. It took me quite some time to convince the team there to use thermal storage and natural refrigerants, but they're working fine over the last 4 years or something. And also with R290 thermal storage, excellent system, in my opinion. Frigo Indus supplied it, so it's even manufactured in Africa. This is a new cold room system from India, and because I'm trying to convince India and manufacturers for many years to use natural refrigerants, and most of them still use whatever 447, which is really harmful. So this one comes with R290, comes with thermal storage, and this system by Global South Health even potentially has the PQS, the WHO. Fulfills the WHO requirements. It comes also with a battery if you want to of 1,000 ampere hours. Because the main challenge, and I've been working with World Health Organization and PQS for many years. They only accept direct solar drive if there's no battery, and we still have to work on that, because of course you need to have a small battery for the thermal storage, for the ice water or whatever, and the fan. So the PQS needs to be changed there, in my opinion. When it comes to direct solar drive vacuum coolers, it's a different story, but for walk-in cold rooms, this won't work. It's a nice container solution, that's why I'm presenting it. Another nice, or 2 examples from Indonesia, cold rooms, walk-in cold rooms with ice production for fish, or I think they even do it with meat. Also using R290. Even the cooling unit is manufactured in Indonesia. You see the one on the left side is a classical cold room. The other one is a container solution with ice storage and a cold room for the ice storage again. Quite a good system. ILK was also involved in the design, and now it's getting scaled also, for example, by UNDP. So this. I was asked to talk about scaling. You see, the first cold room we did with cold hubs in Nigeria, I think we have around 100. So this concept has been copied by UNDP basically, and scaled via the mitigation action facility. And that's an excellent example. 23 million for 1,000 solar-powered cold rooms using natural refrigerants. I made sure that they use only natural refrigerants to reduce the harm. And it's an excellent example to other donors to scale. My conclusions: try really to be F-gas and PFAS free. Use natural refrigerants. use ultra-low GW blowing agents also based on natural blowing agents, and incorporate thermal storage as much as you can. I mean, we have the HFC phase down, and there I mean, what if you install now a system with 4.7 or 4.4? I can promise you, in less than 10 years, there's no more refrigerant available, because these are the first refrigerants that will be phased out. And so what can you do then? You cannot service the system anymore. But also the batteries, as I said, they harm your financial sustainability seriously. And it's like, oh yeah, I had no budget. I had to buy the HFC with the dirty blowing agents and the battery solution because that was my budget. But you need to think about the total life cycle cost and also the total life cycles emissions and environmental impact. Here, two publications. One, I mean, it's a basic one on environmental climate friendly solar working cold rooms, and one on solar cooling technologies I just published. Thank you so much.
Thank you very much.
Questions, please let me know.
Thanks, Philippe, for your insights and your views on the environmental aspects. Very, very insightful. I think there are some questions regarding this topic. I hope we can make it. We are a little bit over time, but now maybe we can give the floor to Sonia, who will be giving us the perspective on the importance of quality assurance. So the floor is yours. Thank you, Sonia, very much.
Thank you, Pablo. Yes, exactly. Quality assurance is extremely important, and that's what Verasol stands for. So Verasol works to increase the access to modern energy services through high-quality off-grid solar products. And currently, 100 million people have improved their energy access from Verasol certified solar energy kits, and that's just a glimpse of showing how important it is to do quality assurance. So why in general is quality assurance so important? First of all, it enables you to make smarter decisions, because once you have access to knowledge, you can compare and make the decisions based on the informations that you get. So that's for manufacturers, distributors, policymakers, development partners, and others. This is really important because that's how they can reduce their risk, but also at the same time increase the impact and improve the overall efficiency, because that's also something that Philip just mentioned. It's also about the whole operation, life cycle assessment, and under that also plays the efficiency of your appliances. And you need to know those things in order to make an informed and smart decision. So how does the quality assurance framework work? So Verasol is a quality assurance program that supports the high-performing, durable off-grid solar solutions. And so first of all, there are test methods which are being developed, which define how product quality and the performance is measured. Then in the next step, testing partners have to be identified that can offer those test lab services, and then also product performance and quality data has to be made accessible. And then, of course, there has to be a baseline of product quality, and then the end step is actually to get certification for the products. So now when we translate that to walk-in cold rooms, why does quality assurance play such an important role for walk-in cold rooms? First of all, that's something we heard from the previous speakers. It's to ensure the performance and the reliability. So because what do cold rooms do? They protect perishable goods and with consistent temperature, and also, you need to reduce the breakdowns and downtimes of your systems to actually make it work. And what Florian said before is you need to know, can you actually afford a breakdown or not? And in most cases, the answer is no, you can't afford a breakdown. And that you can also prevent by having quality assured cold rooms. Then the other thing is also cold rooms are a very high value asset, and the quality assurance therefore would lower your life cycle costs and ensure your durability, so it safeguards your investments. Also, there's a lot of different products out in the world, and especially I feel like especially on the African continent there's a lot of various qualities lingering around, and so people also lose confidence in technologies. If they have their neighbor whose cold room broke down and doesn't work anymore, then they'd be like, is it actually working? So having a quality assurance framework really supports the confidence in the products, for farmers, for distributors, for businesses, and also for the financing institutions, because often those installations are backed by either some projects or by banks, by whatever financing mechanisms which are there. So having a quality assured cold room helps to de-risk the investment. And then also to have a standardized quality benchmark can really help to foster a fair competition on the market, because then they are directly comparable, and therefore you can get your tenders out and you get your quotes back, and so they are better comparable if they all adhere to the same benchmarks. And then also with that, it gets further on the adoption of the cold storage solutions in off and weak grid areas. So what have we done so far? We started with a review basically on what information is out there, what are cold room suppliers providing, what details and spec sheets are there. Then we did a landscape review on those existing things. We set up a test method expert group to then develop a test method for those walk-in cold rooms, of which Giovanni, for example, is also part. And then earlier this year, we conducted the first pilot lab test in Wageningen, and now we are looking to conduct a field test in this still in this year. So we basically have 3 levels of quality assurance. The first one is the product information sheet, which is a standard way to fully and fairly inform the buyers. So they should fill out that spec sheet form, and with that you then, when you have when you're getting various quotes, you can request them to actually fill out that information sheet, and so that makes your different quotations easier comparable, because that's what we saw is one thing that, for example, some providers just give the cooling capacity in kilos per day, others give it in pallets. I've seen a lot of things out there, so really to not be comparing apples with pears. This is a way to really get to the truth of what you're getting back from your tender. And some parameters can become or will become mandatory for the cold room suppliers to be Verasol registered. Others are recommended. And also, I would like to invite all of you, if you would like to provide feedback on how we could improve those sheets, you're very welcome. Please reach out to either me, Elisa. I will put the email addresses at the end of my slides. So please reach out if you're interested to provide feedback on these info sheets. Then the other thing, as I just said, what we did then, it's not just about the spec sheets, but then also a lab test was developed, and it's based on the ATP test protocol for refrigerated containers, and test method from India. And in that the tests that are conducted are an empty pull down test to see how fast the cold room can go from 32 degrees to 1 degree. Then we repeated that test with a dummy load, which is 10% of the total capacity, and the dummy load in our case is bottled water in crates to simulate a load. The steady state effectiveness test is also in the lab test, also of course an autonomy test. We also test for the heat leakage and for the airflow. So all of those tests are there to really see how does the cold room perform against its benchmarks. And then once we build more of a baseline there, they can also be compared amongst each other. And now the next step that we also have in our quality assurance framework is the field test. It is based on the lab test, but it is simplified and shortened because that makes it more affordable, because we all know that testing in a lab is extremely expensive. In addition, if you want to test a system on the African continent, there's only one test lab at the moment in South Africa, which would be able to do this. There is another one in Rwanda under construction. But in general, lab tests are very cost intensive. So that's why we say a field test is necessary too, to actually still test whether your cold room does what the spec sheet says it should do. And therefore, we would also recommend to include such a that field test in your commissioning, because that way, as you get your cold room, you can really see, does it do what it's supposed to do? And it consists of the empty pull down test, the steady state effectiveness test, the heat leakage test, and the autonomy test. Sometimes people ask, why is it necessary? You could also just have your components tested. But if you have been in the field, you see that actually the assembly of your tested component makes a lot of difference to the end performance of it. That's why we think that the field test protocol would be a very viable thing to include in commissioning. Here, as I said, are our contacts. Visit also the Verasol webpage, and please reach out to any of us, me, Elisa, Isaiah, or Jeremy, if you would like to provide feedback on our work that we have done so far. We are happy to share it and to get your feedback by the end of this month. Thank you, everyone.
Thanks a lot, Sonia, for your insights. Unfortunately, we do not have much time for the question and answer section of the session. Thanks to the audience for all the questions. Whatever is not addressed now will be addressed offline, maybe in order to pick one relevant question for you panelists. Maybe we can choose this one. What are the best practice in the markets mentioned so far around disposing solar batteries in a sustainable way? So I don't know who wants to take this one. But maybe in a minute, give your insights on it. I don't know if Philippe or any other that wants to share their insights here. I think you're muted, Philippe.
Pardon?
Now you are online.
Giovanni, do you want to start? I'm sure you're an expert too, and you can explain it better than me.
Oh, I'm not an expert in battery disposal, actually. Possibly you have more expertise in the field. What I know is batteries sometimes batteries from other uses, for example, for cars, are moved to other fields. And so you can use, for example, batteries already used for cars in cold rooms or electric storage. But when it comes to disposal after having been used as electrical storage, frankly speaking, I don't have expertise. Possibly someone from the field, say Philip or Florian.
I mean, you see, you could hear me in my presentation. We usually do not have recycling capacities also in Africa. I mean, GIZ was setting up the first lithium battery recycling facility in Central Africa, which is quite, I mean, in Central America, sorry, in Costa Rica when I was there, Fortech, and they use like urban mining. But I'm not aware about any lithium battery recycling facility in Africa. I might be wrong. I mean, generally, I like lead batteries. They can be recycled easily. Huh? But lithium batteries, I mean, although the prices have dropped and so on, but I mean, even getting the lithium and the footprint of that is already then bringing it to China, producing it, and then shipping it back. That's why I'm against it. But otherwise, we have different recycling technologies. We have pyrometallurgy, we have hydrometallurgy, we have direct recycling, like lead batteries, you can direct recycle. So there's a lot. I mean, there's different technologies, but overall it is complicated. You use more energy again. You need to transport it. I mean, then what are you doing with it? And I mean, most of the batteries are produced in China. Okay, I think we over the time.
Thanks,
Thank you so
thanks
much.
a lot.
If you have questions, let me know. We have a publication on that too.
Thanks a lot, Philip, for your insights. Yes, now it is time to wrap up, and let me just share one final thought. No, because once you have an operational cold unit working, another question rises. No, how do we make financially sustainable in the long run the operation of this cooling unit? No, so this is precisely what we will be covering in our next session for the financing of the cold chain. In parallel to this session, we will be holding another one centered on life cycle assessment. I also invite you all to visit your BCCI website to check on our onboarding kit, where you will have many resources that will help you understand that cooling is not only about infrastructure, that there are many other aspects around, like business models, trainings, etc., as the panelists were explaining in this session. So I hope you find these resources useful. And I would also like to invite you to visit and subscribe to our base newsletter. The QR codes are also shown on the screen right now. So for any queries, you can always write us at info@yourbcca.org. And thanks a lot for the interaction. And I hope we can answer offline all the questions that remained unanswered in the session. Thanks a lot also to the panelists for the insights. And I hope you enjoy the next sessions too. Bye-bye.